I talked about the architecture of StreamInsight before, with the core engine that does the event processing, that executes the queries that I have defined, like the windows and the aggregations, and that does all the low-level stuff, like managing the memory, scheduling the operators, everything that I don't want to do because I want to use a platform, right? I don't want to code this from scratch. That's the value of StreamInsight. How does that relate to the cloud? How does StreamInsight run in the cloud? Well, as I said before, we have created a service here that goes beyond the core engine that I get with the on-premise product. Providing a service means to manage it, to monitor it, to provide an easy way to get data in and out. And this is where I want to start here again, is with the data sources, tablets, phones, web browsers, cars, oil platforms. First, we're collecting the data from them. And as I've shown in the sample, this happens through a built-in, automatically provisioned HTTP endpoint. So any device that can speak HTTP can submit data to Azure StreamInsight. It's not StreamInsight specific. It's not even platform or OS specific. The HTTP standard is old and well understood, and as soon as a device can send that, it can stream into StreamInsight. So there's the collection phase. From here, we go into what we call the ingress stage. And the ingress stage that's already part of the StreamInsight service is supposed to initially process that incoming stream of HTTP packets, which might mean to decode them, deserialize my HTTP bodies into the actual events data, the payload data, the values from my GPS devices in the car, or the telemetry values from the user experience events from the Silverlight video player, and also transform these events. For instance, enrich them with geolocation data. Typical thing that could happen on the ingress stage is to take the IP address, the client IP address, and translate that into an actual geolocation and put that into the events as an enriched event format. And as I mentioned before, ingress runs on one or more cores. So here we're using the Azure Compute Fabric infrastructure. So when I provision my instance in the beginning, I can specify I will need 12 cores for that because I have to do a lot of lookups against my geolocation database, or I need to do other things. I need to do authentication and deserialization. That's compute intensive. So I want to run these things in parallel, not just on one core or one VM, but on a set of them. So that's already a scale-out aspect that does not exist with the on-premise product. One feature to point out here is the ability to not only process the data as it comes in, but also on the side, record it. We call it a spool. Spool the incoming raw data to Azure storage. In our case, it's blob storage because it's the fastest, so that I can later do some offline processing of the data. I can take the data and do data mining, try to find new computations, new queries based on historic data, and use that for offline processing, maybe even with MapReduce infrastructures like Hadoop, and trying to integrate those frameworks from the real time to the historical processing. So that's another feature that provides a value add. Actually already right there, even if I don't go any further, if I just use the collection and the spooling, I already have a nice way to collect data in the cloud. So far, that's what it is. I have an endpoint that's built in. My clients can start streaming into that endpoint, and I turn on the spooling, and I will end up with blobs of incoming data, and then I can do something else with it. So that's one of the value props here. But the main aspect, of course, is then the processing, the temporal processing of the streaming data in the StreamInsight engine. And this is what we would call the analytics stage. After the ingress stage, we go into the analytics stage, again, scaling out over multiple cores, and now doing all the sophisticated event processing, filtering, analyzing, aggregating data over windows, correlating of multiple streams, detect certain patterns in my stream, like my event A, say, alarm on has been followed by alarm off within 5 minutes, so I know it's only a transient alarm, so I can ignore it. All these sophisticated things that are happening over time, they are processed and executed in the core StreamInsight engine. That's what we would call the analytics stage. And again, what is processed there, what executed there, is what I have defined in terms of link queries, what you have seen in Visual Studio before. That is what is eventually executed there. And from there on, we create results which go into the event consumers. And in the cloud, typical candidates here, SQL databases, Azure storage, custom events, things like service bus, like custom WCF services. We want to provide some of these interfaces out of the box. In the current CTP, we're not quite there yet. Part of the sample is an Azure table sync, but that's really just a sample, demonstrating the feasibility. It's not optimized or anything. Eventually, when we go into a general release next year, we want to provide some of these important interfaces out of the box. But there is still the possibility to define, write, and deploy my custom event sync that is then running in the cloud. As well as, by the way, a custom event source. I can still circumvent the built-in ingress stage with the HTTP endpoint by providing my own custom source and use that to stream data into StreamInsight. These stages that are part of the service also have a management and monitoring aspect. So when, for instance, Azure decides to migrate machines, right? It can happen in Azure anytime. Then obviously the service needs to make sure that the queries keep running, that the service of the migrated machines is started again and picking up from where it left off, and the queries are running again. So there's a whole monitoring and management layer on top of that ensures that I have a nice service experience, not just the infrastructure, and I have to take care of that. That comes with the service, and service management have these endpoints I can connect to control my instance and get diagnostics, same as on-premise, where we have the diagnostic interface to get statistics of my event processing, like throughputs and latencies. Same in the cloud. You can actually use the same interface, the same tool. We have this, what we call the debugger, the UI that you can connect to a StreamInsight server to get that statistical insight. You can use the same tool to connect to an Azure instance of StreamInsight. Just looks the same way. Okay, I want to run through a few of the design goals and features and capabilities. And that won't take long because I mentioned most of them in passing already. So for connectivity, what we want to ensure here is that beyond the bare StreamInsight server, we are able to reach out to event sources and sinks, which is facilitated by the RESTful HTTP endpoint that clients can use to get data into, and then having the ability to write expressions over that incoming stream to do enrichment, geotagging, transformations. From there, we provide the analytical capabilities, being able to write the time-based queries, the windows and correlations in time, but also plain sequential queries, reactive queries. StreamInsight, since its latest version 2.1, in the cloud as well as on-premise, is becoming a host for both kinds of event computations and queries, whether it's time-based or whether it's plain sequential without time as a special property. So StreamInsight is basically a host for reactive and temporal queries. And then scale. One of the important aspects here is to be able to run that transparently across Azure cores without having to scale out manually, which is what people need to do on-premise. Since this is not a built-in feature, it's not very complicated, and we see many use cases doing that, scaling out over multiple machines, but I have to do it myself. In the cloud, we are providing that as transparently as possible. Security I mentioned briefly in the context of the endpoint with HTTP and HTTPS. In addition to that, we also want to provide client authentication, not just service authentication with SSL, also client authentication. We will eventually, we are planning to use ACS for that. And one other security aspect is that, and I will talk about that also later, is the fact that we don't share Azure instances. It is, in fact, a single tenancy service where the cores and the VMs that I request for my StreamInsight instance are dedicated to me and to my queries, and nothing else runs there, which makes security and privacy much easier. I briefly talked about monitoring, being able to, for the service, being able to automatically restart computations, queries, and the whole service, and also being able to send out notifications. So that's one of the service aspects we're providing, as well as tooling support, being able to log and trace in my user code. You've seen that there's a lot of, or there can be a lot of user code running. I can deploy DLLs to the Azure instance that are then called from within my queries. And that means that potentially procedural user code is running there, and I want to be able to trace from there, because naturally debugging in the cloud is difficult, right? I don't have direct access to the machine. I don't have good insights into what's happening at any point in time, so I need tooling for that.